So we are now at the fourth lesson in chapter 5. This lesson is called the distributive property, and we didn't include this with the last video because this property is so important that it gets its very own lesson, very own video. Let's get started. So we're going to start with some vocabulary. We'll start with the term the distributive property, and the distributive property is the property that allows a factor to be multiplied to each term inside a set of parentheses. So basically what that means, if we look at example 1 right here, we're going to have a number outside a set of parentheses touching the parentheses, which you know that means that we're going to be multiplying. And then we have this set of parentheses with a problem or even 2 or 3 problems inside. This property allows us to multiply that number into those parentheses. And you may ask, well, why would we want to do that? Why can't we just follow the order of operations? Well, in some cases, we could do it either way. We could follow the order of operations, we can subtract the terms or add the terms inside the parentheses, and then multiply later. But in a case like this, we can't take x minus 9. They're not like terms. We can't subtract them. So the only way we can simplify this expression is to take our 10 and multiply it to both terms inside of the parentheses. And this is the work I like to see shown to make sure that you know you're doing your multiplication in every place possible. So first we're going to take 10 times x. 10 times x is 10x, and we're going to write it like this. You know that a number next to a variable means multiplication. Then we are going to do a little multiplication with our signs. So this is a positive 10. It's not written there, but we can write it there just in case. A positive times a negative will give me a negative. I know that looks weird because you're saying, hey, that's a minus sign. It is, but we also have to do our sign math too. So a positive times a negative is a negative, and then 10 times 9 is 90. That is our simplified expression because we cannot subtract those two terms. Okay, let's take a look at number 2 here. We've got a negative 5, so this time we're going to have to be cautious to be keeping that negative sign in the problem. So we'll start with a negative times a positive is a negative. 5 times 6m, 5 times 6 is 30, and bring that m along, we get negative 30m. Now, that negative sign and this minus sign, we have to multiply them together to make sure that we end up with the correct sign in our problem. So a negative times a negative is a positive. And 5 times 4k, well, 5 times 4 is 20. So 5 times 4k is 20k. M and k are not the same variable, so those are not like terms, which means we cannot add them together, and we are officially simplified. Number 3, I wanted you to see an example like this for 2 reasons. Number 1, I wanted you to know that you can do this for multiple terms inside of parentheses, not just 2 terms. And I also want you to see that this is kind of a weird one here. We have just a negative sign outside those parentheses. That's it. So we have 2 ways to think of this, and I'll show you both thought processes. The first one is to just take your sign and multiply it to each term and see how it changes them. That's pretty easy. Let's do it. So we can start here. A negative times a positive, because that's a positive 4b. A negative times a positive is a negative. The 4b just comes along for the ride. A negative times a positive is a negative. The 2a just comes for a ride. A negative times a negative is a positive, so that makes that a plus sign now, and the 9 just comes for a ride. So that's one way to do this problem. If you're happy with it that way, I'm totally happy as well. There is another way to do this problem, and that way would be to use our multiplicative identity property. If you think back to the videos in 5.3, the multiplicative identity property says we can multiply anything by 1 and we will not change the product. So what we can do here is we can rewrite this problem, and after that negative sign, we can put a 1. And then the quantity of 4b plus 2a minus 9. And some people like this better. Some people like the 1 there so they can see what they're multiplying into the parentheses instead of just multiplying a sign. So let's do it. We're going to draw our sign to show that we're doing all of our multiplications. Negative 1 times positive 4b. A negative times a positive is a negative. 1 times 4b is 4b. Negative 1 times positive 2a. A negative times a positive is a negative. 1 times 2a is 2a. A negative 1 times negative 9. Negative times a negative is a positive, so we put a plus sign there this time. And 1 times 9 is 9. See, we got the same answer. So either method works for me. If you're comfortable just multiplying the sign into the problem, that's great. If you'd rather see a number, then let's utilize that multiplicative identity property and put a 1 in that place, and that'll be perfectly fine. I have one more example here for you. This is a word problem that we can use to demonstrate where we might use the distributive property in real life. It says, Mr. Ito needs to buy batting helmets and batting gloves for the baseball team. The helmets he plans to buy are $19.95 each. The batting gloves are $7.95 each. Find the total cost if Mr. Ito needs to buy enough equipment for all 14 players on the team. So we need to buy a helmet, and we need to buy batting gloves. But we're not just buying one set, we're buying 14 sets. So this is where we may use our distributive property. And the reason we would do this is because we're doing a helmet and a batting glove. We're buying that same purchase 14 times. And if we solve using the distributive property, we can take our 14 and multiply it into the problem. So really quickly, I'm going to use a calculator to speed these multiplication problems up. But the first problem we can do is 14 times 19.95. And I'm getting $279.30. A positive times a positive gets me a positive. 14 times $7.95 is $111.30. And then I can follow my order of operations and add them together. And I get $390.60. That might not be the way that you would solve this problem, but it is a way that we can use the distributive property in real life context. Okay, go ahead and do your practice problems. Ask any questions in class tomorrow, and we'll talk more about this in class.